All right, so here is the problem that I've already worked out, just so you can see the point values for the different sections. All right, so as part of the Pew Internet and American Life Project, researchers conducted 2 surveys in 2012. The first survey asked a random sample of 799 US teens about their use of social media and the internet. A second survey posed similar questions to a random sample of 2,253 US adults. In these 2 studies, 80% of teens and 69% of adults use social networking sites to construct and interpret a 95% confidence interval for the difference between teens and adults who use social networking sites. So we've got 2 populations we're interested in: adults and teens, 2 separate populations. And we want to know the parameter of interest, the proportion who use social networking sites. So in the state section, I've got to list both parameters I'm interested in. P of T is the proportion of teens that use social media. P of A is the proportion of adults who use social media. And I want to estimate the expected difference with 95% confidence. So that would be 3 points in the state section. The way that we can compare is a 2-sample Z interval. So that needs to be said in our plan section. Then we have to check the conditions for both samples. And this is something new right here. We have to say that both are independent because the samples cannot influence each other. If the samples depend on each other and they're not independent, then we can't proceed with the Z interval. So we have to make sure we say that both samples are independent simple random samples. Next, we check the 10% condition. And it's safe to assume that there are more than 7,990 teens. So our sample is less than 10% of teens, and our sample is less than 10% of adults. Then we check the large counts, and we use the actual sample that they gave us. So 799, they told us 80% use social media, so 639. And the number of failures, 160 don't. Same thing for the adults, multiply it by the proportion that they gave us. And all of these values are greater than 10, which tells us both sampling distributions are approximately normal, which means the sampling distribution of the difference will also be approximately normal. So we're good to proceed with this two sample Z interval. So finally, we can look at the do section and just use the formula that we discussed. So the point estimate is the expected difference from our samples, plus or minus critical value times the standard error. So you can see I've worked out the standard error here already. So it's just the sample of teens plus the sample of adults, take the square root, and we get a standard error of the statistic of 0.072. If you don't remember how to find the critical value, we can talk about that in a second. We have inverse norm. So if it's 95%, you've got the middle 95%. So that means there's 2.5 below and 2.5 above. So the 2.5th percentile would be 1.96. That should be familiar to you. And then we just simply plug in our values. Our sample from teens was 0.8. Our sample from adults was 0.69. Critical value is 1.96. And the standard error, which was right here, we're just plugging that in. So then we get our confidence interval from 0.076 to 0.144. You should be thinking to yourself, all of those values are positive. So we have reason to believe that the first proportion, which would be teens, is larger than the second, which is adults. So we're 95% confident the interval from 0.076 to 0.144 captures the true difference in proportions of all teens and adults who use social networking sites. And so that's the goal, to try and estimate and capture the unknown difference between these two populations. So in this do section, I'm looking for point estimate is a point, critical value is a point, standard error is a point, and then of course the correct value or the interval is a point. And then the conclusion, need to say the level of confidence, need to say the interval, and you need to say the context of the problem. So in this case, it's the difference in proportions of teens and adults. So in this case, we have evidence, we have convincing evidence that there is a difference because all of our values are positive. If if let's just say this was a negative value here and it goes up to a positive value, that would mean 0 falls in the interval. And if 0 is in the interval, then we don't have evidence of a difference because 0 is a plausible option. So that's another way that problems like this could go. But in this case, we do have convincing evidence that there is a difference because these are all positive values and 0 doesn't fall in the interval.